Good evening, everyone, and welcome to the 61st Bay Area Science and Engineering Fair Activity Week. My name is Maya Clapperton.
And I'm Serena Mogus, and we are your student advisors for the fair this year. There's a Q&A function where you can ask questions throughout the presentation. If time allows, we will answer your questions at the end of the session. If we are unable to answer your questions during the session, we will also post a Q&A on our website along with the recording of this event. Tonight, engineering students Sophie Nasato and Julie Minetti from McMaster Engineering Venture Academy will take us through the exciting STEM-based learning opportunities provided by Venture Academy. So sit back and enjoy.
Great, thank you so much. We're so excited to be here. I'm gonna go ahead and share my screen now, and then we'll get started. Okay, so now that we can see my screen, then we're all set to get started. So thank you so much for having us. We are so excited to be here today on behalf of Venture Academy, which is out of McMaster University's Faculty of Engineering. So here we are going to talk to you all about the programs that we offer at Venture Academy for students in grades 7 to 12. And then we're also going to talk to you about things beyond that. So we're going to talk to you about what it's like to be a student within the Faculty of Engineering. And then you'll have a chance at the end to participate in our Q&A session where you can ask questions directly to students that are current students in McMaster's Faculty of Engineering. So you can start brainstorming right now some questions you might want to ask current students. Awesome. So before we jump right into our content, we thought it would be good to tell you a little bit more about ourselves so that you know who's chatting with you today. So a little bit about me. My name is Julie, as they mentioned. Thank you for that warm welcome. And I'm currently a fourth-year biotechnology student. So that means that I love to study biology concepts on a really, really small scale. So things like bacteria and viruses, but then I also like to study things on a really, really large scale. So how can we mass produce different pharmaceuticals and different vaccines, especially, so that we can help everyone in the whole world. So I like that different concept of how do we scale up processes so we can help a lot of people is really interesting to me.
Awesome. Thanks, Julie. And my name is Sophie, and I am a current Master of Engineering and Public Policy student at McMaster University. So right now in my program, I'm learning about the merge between all things and technology, engineering, and government. And then previously, I just completed a degree in chemical engineering, also at McMaster. So in that program, I learned a lot about process engineering and optimizing those processes to best serve the needs of different functions. And I'm really excited to be here with all of you as well. Perfect. So first thing we're going to do is discuss who we are from Venture Academy and what our goals are. So at Venture, we really strive to bring the excitement of science and engineering to life for all students in SK all the way to grade 12. And we do that by completing hands-on activities that allow students to have a lot of creativity, growth, and really encourage a big passion for learning in general and for a really big idea on discovery.
So we mentioned that we're here today from McMaster's Faculty of Engineering. We mentioned that Venture likes to bring the excitement of science and engineering to life, but what does that exactly mean? So we'd like to hear from you, your ideas currently on what you think engineering is. So if you want to use that Q&A function that was mentioned at the beginning of this presentation, we would love to hear from you. So you can share anything that comes to mind when you think of the word engineering. We'll give everyone a minute to think about that. It could be really anything. If you've heard of different types of engineering, you can share that with us. If you want to share what you think an engineer might work on, what they might do for work, you can share that as well. If you want to think about what maybe engineering students do, that's who's talking to you today, you could share that. So anything you can share. This is a very open-ended question. We'll give everyone a bit of time to think. I know it might seem like a really big question because it's so general.
Do you see there, Julie, I wrote out a published question so people can reply directly. Did you see that as well?
Yes, I did. That's perfect. That's really helpful. So yeah, feel free to respond to that question for us and let us know what you think it means.
I love it. Okay, awesome, Julie. Yeah, you answered your question in a lovely way.
Thank you. So friends join us later on, and they are curious the answer to that question. I also responded in the chat box for us. So when I think of engineering, I think of designing creative solutions. And that's a broad answer for a broad question, because engineering means so much to so many different people. But there are a lot of different problems that our society faces, and engineers design creative solutions to help solve those problems. So that's why we have so many different types of engineers, because there are so many unique problems that need unique skill sets. So that's what engineering means to me.
Awesome. So at Venture Academy, we really advocate for diversity and inclusion in STEM fields. So we offer a wide range of programs in which we engage with community partners, which we'll introduce shortly, to best serve the interests of the STEM field by having a diverse group of people involved in it.
Amazing. So representation in STEM is what's really, really important to us. So when we talk about representation and that advocacy that we're doing, what we're really trying to achieve is a set of engineers that are designing solutions that benefit our entire society, not just a portion of it. So when you think about our society and how diverse our society is and how we need solutions for everyone in our society, you need a group of people designing those solutions that actually reflect the members of our society. So that's what we really strive for at Venture.
Awesome. So you can see here a representation of women in engineering, specifically at McMaster University. So you can see that over time it has been awesome, because the amount of women in engineering at McMaster has increased. In the past academic year, we saw the highest value or number of women in engineering we've ever seen, in 35%. However, although this number is excellent and the improvements are so important, we still have a long way to go. Women make up 50% of the population. However, only 20% of women are engineering students in Canada, and only 13% of licensed practicing engineers are women as well. So those steps in getting diversity and inclusion in STEM start here, and it's in all the work that we do and all the work that you as students engaged in a science fair do as well.
Definitely. So there's that little goal that popped up here. So Sophie mentioned how we're continuing to grow and work, and that's a really interesting goal that was set out by Engineers Canada, which is they call the 30 by 30 goal. Sorry, I didn't pop that up sooner, but it's really interesting. It's a goal set out by Engineers Canada, which states that their goal is that by the year 2030, 30% of newly licensed engineers will be female. So it's a really exciting goal, and we hope that we get there by the year 2030. So Sophie mentioned earlier our community partners, and I'd love to expand on these community partners, because we do not do the advocacy that we do for the STEM field alone. We work with amazing community partners. So here are just some of the community partners we work with, specifically to support young women in STEM, Black youth, and Indigenous youth. So we work with the Ontario Network of Women in Engineering. We work with the National Society of Black Engineers, which is specifically the McMaster chapter. We love working with McMaster-based groups, of course. And then we also work with a school that is called Six Nations Polytechnique. So these amazing community partners really help us amplify the voices of underrepresented groups in STEM.
Awesome. So now that you know about the different community partners and how we achieved diversity in our programs, we'll now touch on the different programs that we offer, and they are all actually virtual right now as well. So we have workshops, and those are actually done in classes. So even virtually right now, we have workshops for teachers that they can do within their classrooms. At Venture, we also offer summer programs. So we'll dive into that just a little deeper. And we offer camps. For the older age groups, we refer to them as programs, just because it is really an awesome learning opportunity in the summertime. We also have events. So those are typically one-day events in which we do a project with students and offer a mentorship aspect to our program in general. We also have clubs, so these are after-school clubs for specific age groups and specific learning goals. So for example, this past fall we had a high school AI coding club, which was a lot of fun. And then all of these together are representing Venture Academy as a whole, but more importantly, McMaster and McMaster Engineering. And you can see the fireball there is McMaster Engineering's main logo.
Awesome. So now we're going to do a spotlight on some of our programs that are specifically available this summer for students in your age group. So for students in grades 9 to 12, we specifically wanted to highlight the two programs that we have available. And those two programs are the Computer Science and Engineering Physics program. And the really exciting part about our summer programs is that we will be mailing out an at-home STEM kit for every single participant. So we like to call this Camp in a Box. So we're going to bring all of the excitement of science and engineering right to your front door so that we can continue to connect with you, even virtually. So if you are interested in these programs, a little bit more details about them is that if you're interested in the computer science program, you're able to dive into all of the excitement of computer science, software engineering, and all of the principles and theory that goes along with that, while learning really valuable coding languages like Python, Lua, C#, C++, and also JavaScript, which is really, really exciting. So if that sounds exciting to you, you probably really love software and you probably love coding and really anything that goes on, I like to say, on the screen of your computer, of your phone. Anything that happens on the screen is made possible by software engineering. So that computer science program is a really interesting way to learn about that. And then in our engineering physics program, you'll be able to learn about principles of mechatronics, electrical, mechanical, and computer engineering. I know that sounds like so many different types of engineering, so you're probably wondering, how are you going to encompass this in a one-week program? But we're going to do it, and it's really exciting. So you really get to learn about a lot of different types of engineering in this stream, which is what I find really exciting about it. So you'll explore things like breadboarding. So if you've ever built an electronic circuit before, if you've never built an electronic circuit before, this is a great place to start as well. You can use tools like Arduino and explore computer programming, which is really exciting through these streams.
Awesome. So beyond the actual opportunity to attend our summer programs, we also have a volunteer opportunity known as Leaders in Training. So our Leaders in Training program is actually virtually new for the first time this summer, and we're really excited to be able to offer this for high school students. So any students entering grade 9 to 12 in September 2021 are able to apply for this program. And essentially, this program allows you to get your 40 hours of volunteering that's required for high school graduation in Ontario. But more importantly than that, in this program, you're able to develop leadership skills by mentoring younger students in our STEM programming. Additionally, you get amazing mentorship experience from McMaster Engineering students because all of our staff are McMaster Engineering students, so you get to work directly with them. And then you also gain a valuable working experience, which has a large amount of transferable skills that can be used in any job or place of or any experience moving forward, which is excellent, a good way to build your resume for sure. And then last but not least, you get to develop your technical skills because in our programming, no matter the age group, we really do focus on digital literacy skills. So all things 3D modeling and coding and software are embedded in our programs, and you definitely get to develop those skills. So the application for our Leaders in Training program is open and available on our website. We do have our deadline coming up shortly on April 5th to then decide on which Leaders in Training will be joining us for the summer months.
Awesome. I'm so excited to meet some amazing high school students this summer. So next, now that we've talked about everything that Venture Academy does to support youth, we're going to talk about McMaster Engineering beyond grade 12. So we've talked about everything up until that point, and we're now going to explore some post-secondary programs. So you have a lot of different opportunities once you graduate from high school, but we're specifically going to talk about McMaster Engineering as an opportunity for post-secondary education within a STEM field. So when you think of McMaster Engineering, I'm sure you think about all of the different academic programs, but one reason that a lot of us chose McMaster Engineering is because of this principle that our faculty really strives to achieve, and that is the degree plus experience goal. So that means that when you choose to become a McMaster Engineering student, you're not only committing to your academics, but you're committing to that amazing experience that you get outside of the classroom. I know I can speak personally to this. I've loved all of my experiences outside of the classroom just as much, sometimes a little bit more than what I'm doing in the classroom. And that's exciting because you really get an entire experience when you go to McMaster Engineering. So we're going to talk about what degree plus experience actually means a little bit more.
Awesome. So degree and experience, what does that mean at McMaster? So there are a lot of different ways you can gain that experience aspect at McMaster in engineering. So the first way is through co-op opportunities. So these opportunities are actually very flexible in nature at Mac, and you can have an opportunity to work with a company and gain valuable work experience that's either 4 months in length, 8 months in length, 12 or even 16 months in length during the time that you are a student. Another way that you can gain experience is through social impact. We have a lot of really great initiatives that strive to make a positive change in our world, and that's a really great way to expand on your degree. Additionally, we have a lot of ways you can innovate with your degree. We have awesome facilities on campus that definitely best encourage innovation and allow for students to learn beyond the classroom. So that's an amazing way to also make a difference and maybe really apply the things you're learning in school. Another method is through clubs. Personally, I love clubs. It's great to find people of similar interests to do things that you enjoy together. So that's an amazing way to expand on your learning and your time at McMaster. Additionally, there's research opportunities on campus, especially in engineering. Most professors actually do conduct research in addition to their own teaching, and they do take on a lot of students to do research in their labs. So it's an awesome way to do research. You also can do a lot of research typically in your classes as well, based on the nature of your program and the opportunity to be in labs and whatnot. And then lastly, it's just you can have a balanced lifestyle with your degree at McMaster. So one thing that comes to mind for that is going to the Pulse, which is the gym at Mac, and an awesome way to be a person beyond the degree in which you're studying.
Awesome. So next, if we've gotten you so excited about the environment at McMaster Engineering, if you're thinking this is where I want to study, now you can start kind of thinking about what you might actually want to study. So the Faculty of Engineering at McMaster offers 4, we call it level 1 entry programs. So there are actually many more programs than just the 4 you see on this screen within McMaster Engineering, but those decisions come in second year, and we'll talk about that a little bit later on. But these are the 4 programs that you can enter coming straight out of grade 12 or entering your first year at McMaster. So the first one I want to talk about is the B.Tech program, because that's the program I'm in. So I'm obviously very excited to talk about it. So the B.Tech program is a really interesting program in the Faculty of Engineering, because we have 3 programs that you can actually specialize in your first year. So those 3 programs are biotechnology, automation, and automotive. So there's longer names, but that's what we shorten them down to. And the really interesting thing about this program is that we focus on hands-on experiential learning. You get that in all programs in the Faculty of Engineering, but that is actually the primary focus of our degree. So we spend a lot of time in the lab. Biotechnology students, by the time they graduate, actually spend upwards of 750 hours in the lab, which is really interesting. So that's what we like to focus on. And this program is also interesting because it is a joint partnership with McMaster and Mohawk College. So when B.Tech students graduate, they'll get a Bachelor of Technology from McMaster. They'll get an advanced diploma in their specialization. So remember I mentioned there was 3. And then we'll also get a certificate of business from Mohawk College. So that's a unique program that takes a little bit more explaining than some of the other programs, just because of that little partnership there, which is really interesting. Next, we have the computer science program, and the computer science program is an amazing program at McMaster and in McMaster Engineering because it's actually the smallest program in our faculty. So that's really awesome if you like a tight-knit community and if you really love software. So if you absolutely love computer programming and you want to know more about the actual theory of what goes into computer programming and the how and why everything is working in your computer, computer science is for you. So if you like things like design and specifically software design, this would be a great program for you. And because of that small, tight-knit community, you have a lot of amazing resources and peers to connect with. And in addition to that, a lot of the courses you actually take are electives, which means that you really get to customize your degree to be what you want it to be. And the next program is the iBiomed program. So the iBiomed program is a really fascinating program to talk about because it is very unique to Canada. And this is a brand new program. I believe our first graduating class is actually going to be graduating next year. It's a 5-year program, so brand new. No one's even graduated from it yet, which is so exciting. So this is a joint partnership with the Faculty of Engineering and the Faculty of Health Sciences. So if you love how technology can work with human health to benefit people, then this is a really cool program for you. So in your first year, you have a general first year, and then in your second year, you can choose if you want to focus more on the engineering side of things or the health sciences side of things. And then you make that decision in your second year. If you choose to go the engineering route, then you have a whole other set of decisions to make, and you can choose to combine your biomedical engineering background with any other stream of engineering, which we'll talk about soon. And that actually leads nicely into our engineering program, which is an amazing program. It's the largest program in our faculty. Also, I think it's safe to say it's been around the longest. And this program also has a general first year, which is a really great way to learn more about what you truly want in engineering, because there are so many different types of engineering, and you try your best to learn as much as possible in high school about the type of engineering you want, but it's really nice to have that extra year to learn more about all of the different types of engineering that's offered at McMaster. And another really unique thing about the engineering program is that there's this amazing course in first year, which is actually a project-based course. So we call it 1P13, and it's a brand new course where you can really focus in on innovation and engineering design and getting that experiential learning. So those are all of the different programs that we offer at McMaster Engineering. And now we're going to focus in on the engineering stream, and we're going to talk about those specializations that you can go into in your second year.
Perfect. So if you think that the engineering program, also known as Engineering 1 or iBiomed program, is something you're interested in, you will then enroll in that in your first year, like Julie said, but following your first year, you get to specialize. So just before I explain each one, I just want to explain that the chemical engineering and bioengineering and computer engineering streams are not offered with iBiomed, but the remainder are. And then if you enter Engineering 1, all of these programs are available to specialize in into your second year. So starting off with chemical engineering is definitely the easiest one for me to explain because that is what I pursued. But chemical engineering is actually more of a process engineering approach, and there's a lot of different areas of specialization. Specifically at McMaster, you can specialize in polymers, in water, or in optimization. So there's actually a diverse range of options even within that faculty that I know of specifically. Sorry, in that department is what I meant to say. Additionally to chemical engineering, we have the chemical engineering and bioengineering program, which is a 5-year degree and really extends chemical engineering knowledge to a biology application. And that's not just necessarily human health and medical biology, but rather biology as a whole, and really looking at process optimization for a lot of biology-based things. Next, we have civil engineering, which definitely is a combination of structural, water, and transportation at McMaster. So if any of those areas are something you're interested in, that's somewhere you can specialize. Next, we have computer engineering, which is more of the hardware side of computers and understanding the different components and the ins and outs of a computer for sure. But you also do a substantial amount of coding in computer science as well. Sorry, in computer engineering as well. Next, we have electrical engineering. So if you've never made a circuit before, that is okay. But essentially, it's taking circuits and expanding it into a wide range of realms and really working with the voltages and currents and all those things in much greater detail than I can pretend to understand. Additionally, we have engineering physics, which is a pretty neat engineering stream that really encompasses kind of discovering how each part of science works and taking advantage of the fundamental aspects of physics in order to apply engineering solutions. For example, I took a course in engineering physics called biophotonics, so we use the principles of light and microscopy to develop biology solutions, which is pretty cool. Materials engineering is really the fundamentals of chemistry and taking advantage of those fundamentals to be applied into engineering solutions. Mechanical engineering is taking advantage of moving parts and processes that involve moving parts to design solutions. Mechatronics is kind of a merger between electrical and mechanical engineering. It is what the name says, so those two definitions combined. And then lastly is software engineering. So Julie really nicely introduced computer science, and it's taking computer science, but developing more on the innovation side, I would say, is what separates that software engineering from computer science. And don't take anything what I say here verbatim. I'm not an expert in all of these specializations at all, but that's just a little introduction on how I understand them personally.
Awesome. It's so exciting to hear about all of the different programs. I know it's so much information because we offer so much, which is exciting. So the next thing we're going to chat about is the admissions requirements. So if you are not in grade 11 or 12, you're probably thinking right now, slow down, Julie, I'm not there yet, and that's totally okay. The reason we're bringing this up is so that you can kind of start to align yourself with these programs if this is something you want, because they each have different and unique prerequisite courses that you would need to take in high school in order to be eligible to apply to these programs. So that's why we thought we would bring this up now and encourage you to keep your doors open and take the required science courses, just so you have the option if this is something you may be interested in down the road. So with engineering 1, iBiomed, BTech, and computer science, you do require English for you. You also require calculus for you for all of them. And additionally, they all require chemistry and physics. So now a unique program is iBiomed because it actually does also require you to take biology. That means you may need to take all 3 senior sciences that are offered. And then, of course, they'll take some other courses to help generate your final average. And with respect to those minimum averages that are listed there, please take all of these with a grain of salt because they change every single year. So by the time you get around to applying, if you're not in grade 11 or 12, then these may not be relevant anymore. And also, my best advice to everyone when you're looking at these minimum averages is to just try your best, because really that's all you can do. Whatever you're studying, you want to make sure that you are happy studying it and you're passionate about it. So just make sure that you're trying your best in the courses that you're taking, and see what programs that aligns with. So that's my advice for all of these admissions requirements, is to keep your doors open and just try your best with respect to those averages. So if you do have any questions specifically about admissions requirements, Sophie and I are not the experts in that. We focus on youth programs, so everything before this point, so everything before that application process starts. So I would encourage you to email this email that's on the slide here. It says thinkeng@mcmaster.ca. There's also a lot of amazing admissions resources on McMaster's website. So again, we're not here to talk to you all about the application process. We are here to just encourage you to explore science and engineering as much as possible in high school so that you consider it in your post-secondary opportunities.
Awesome. So this is a very nice visual to see the suggested course pathway in order to get an engineering degree per se, but even any other science or technology-based programs have a very similar pathway as well. So this kind of is all-encompassing. So Julie did a nice job of explaining all the courses required in grade 12, but this is a nice way to see the courses prior to that. So of course, your math, science, and English are your required courses in grade 9 and 10, and then in grade 11, the science is specialized, so you get to take your chemistry and physics. And then your math is referred to as functions. And one important note is that it is a U-level course in order to attend a school in Canada for engineering. And then The only greater specification from grade 11 to grade 12, the major change there is that in addition to your functions course, in addition to your advanced functions course specifically, you have to take calculus and vectors. So you can see the nice branch there from one to the other, and they expand nicely into one another.
Awesome. So we've talked about a lot of information from getting involved with us in our youth programs this summer, all the way to how you can apply to McMaster Engineering if that's something that you would be interested in. So with that, we do really hope to see you virtually, of course, this summer. So we wanted to remind you that registration is open for our summer program. So if you were interested when we were talking about all of those different types of engineering and what they mean to us, if you'd like to further explore that with us this summer, we would love to see you participate in our program. So again, you'll get that exciting STEM kit mailed right to your front door, and you'll be able to connect virtually with us to go through all of these projects as a team. Additionally, registration for our Leaders in Training program is now open, so you can feel free to apply to that. We would love to see you all apply. We are looking for exciting students that are excited, about science and engineering, and we would love to see you participate in our program that way. So if you would like to stay connected with us and get some more updates about what we're up to at the Faculty of Engineering, and specifically with our youth programs, then this is a list of how you can stay connected with us. This is probably a good slide to screenshot if you'd like to remember. So our website is youthprograms.eng.mcmaster.ca. So if you would like to register for our summer program, or if you would like to apply to be a leader in training, then you would go to that website to check out all of the information there. And then we do also have an Instagram and Twitter account and a TikTok account. Yes, we are hip and happening. We're really excited about that. And all of those handles are at MacEngYouth. And then our Facebook and Twitter, our Facebook and LinkedIn is Venture Academy. So that's how you can stay in touch with us and get to know what we're doing. So with that, we thank you so much for listening. So do you have any questions at all about anything that we discussed in our slides before we jump into our panel discussion, which is going to come next?
We definitely have a couple questions in the chat there if you guys want to take a look.
Yes, for sure. I see them there. Julie, you see them as well?
Yes, I do. Amazing.
Awesome. So I guess it's easiest to leave this slide up. But before we begin, perhaps we should introduce our panel. I think Angel's just joining us shortly here, but to introduce Shelby, who's joined us here today. Shelby, if you want to introduce yourself and explain your program and everything, that would be amazing.
Yeah, hi everybody. My name is Shelby. I am a third-year biotechnology student at McMaster University. So the exact same program Julie is in. We're actually in the same year, but it worked a little differently for us. We basically do a lot with bacteria, and we do a lot of lab work. That's actually one of my favorite parts. And for me personally, I definitely do love more of the chemistry and biochemistry part of biotechnology, which is an awesome program because you learn a lot of things that can lead you into many different pathways.
Amazing. Thank you, Shelby. And additionally, we have Angel here. So if you want to introduce yourself and introduce your program and explain it a little bit to everyone, that'd be perfect.
Yeah, sure. Hello, everyone. Sorry I'm late. My name's Angel. I'm a third-year student in automation BTech. So in my program, I do a lot of robotics. I do a lot of electrical engineering, a lot of breadboarding, lots of programming, lots of chemical engineering. And I focus a lot on the automation industry, so it's a fun experience.
It's amazing. Thank you, Angel. So, Julia, you're good to read out questions, and then one of us four, we can just kind of take turns and answer what we feel is best suited for us from the chat. But to all of you who are here as attendees, please feel free to ask us questions that are about McMaster Engineering, about our specific programs, about admissions, things we do outside of school. We're more than happy to answer any of those questions. So, Julie, if you want to take it away on reading them, I think that would be perfect.
Yeah, of course. There's one question that I think I'm going to pick out to start with, just because it does pertain to our slides a little bit. So I might direct this one to you, Sophie, before we jump into our other questions that will be for our whole team. So someone is asking a little bit more about our volunteer opportunity and is wondering what kind of experience will you be looking for applicants to have?
Awesome. That's a great question. Thank you for that. So our Leaders in Training program is really looking for individuals who are excited about science and engineering, not just excited personally, but also excited to share that passion, because we want to be amazing role models and mentors for the younger students that we're working with. So that is probably the main thing that we can ask for. But otherwise, in addition to being passionate about science and engineering and sharing that knowledge, we also are looking at any skills leaders in training applicants may have that are related to science and engineering. So any coding experience or any 3D modeling experience is considered an asset, but not necessarily required. And other than that, just people who are excited to work as a team and to be collaborative and really take on new challenges to learn a lot. So I think those are probably the main things we're looking for our leaders in training applicants.
Awesome. So I think we'll jump to our next question for our whole panel. I know everyone has unique experiences, so it'd be interesting to hear different perspectives on this. So the question is, has it been hard to find good co-op jobs with the COVID-19 pandemic?
I think I can get started on this because I think I'm the person that most recently landed a co-op at Venture Academy. I actually just came from another McMaster engineering recruiting event, so I've been hearing a lot more stories from current students on how they've been finding the co-op this season. And to summarize, has it been difficult? That is debatable because if you really did all of your preparations early, if you started applying very early, there are many opportunities out there presented to everyone. So you also have to make sure you use your resources correctly. So if you come to the our ECCS office, they help you with interview tips, resume critiques, cover letter checks, and those items would really help you to land at co-ops. And yeah, some general advice would be apply early, and you should be fine.
Awesome. Thanks, Angel. I think that's great advice. And I think I can add on to that a little bit. A little bit of background knowledge about me is that I'm actually an ambassador for McMaster Engineering's co-op program. So I'm really passionate about co-op. I'm really passionate about experiential learning. For any friends on the call that have maybe you've never heard the word co-op before, co-op means it's a job that you do get paid for that directly connects to your degree. So you can somehow prove that you are learning engineering principles while also on this job. So it's a really, really great way to gain learning experiences through work, which is great. And I can say from what I've heard from different people in the co-op program, I think Angel did a really great job of summarizing it. But last summer, there was quite a dip in co-op jobs because the whole world was trying to sort everything out, right? But now it's been really exciting from my end to see how different organizations have actually pivoted their co-op programs. So they've now been able to say, okay, we know we want students, we know we want them remotely. How can we make this working experience as enriching and as exciting as possible with these students safely at home? So I would say that has it gotten harder? Maybe a little bit because there are slightly less jobs, but we're seeing an increase now, and it's become a lot more exciting, I think, because there's now new co-op jobs, new programs, and it's been really interesting to see that shift in industry with how people are now exploring their jobs, which is really exciting. So there was one question here. So I think I'm going to I think I'm going to start with one question, which is what kind of jobs would a chemical engineer have after university? So I'm going to direct that one to Sophie, but then someone earlier on asked, what is the job market and postgraduate employment opportunities looking like? So I think we can kind of tie this one together and maybe everyone can share what they're hoping to do after university and what their job or additional schooling experiences are looking like. So Sophie, if you want to kick it off, and then we can go maybe to Shelby and then Angel.
That's perfect. Thanks so much. So I guess I really like this question. What kind of jobs would a chemical engineer have after university? Because my answer maybe is comical, but it really is anything that you would like, because chemical engineering is a really diverse field in which you learn about process optimization that's not specific to any sort of industry. So personally, I know people who are in the food and beverage industry with their degree working at PepsiCo. I know people who are manufacturing steel at ArcelorMittal. I know individuals who are actually doing coding at different programs, because you do learn fundamentals of software and computer science as well in a chemical engineering degree. So the ideas are endless. Oh, and one other specific area I want to touch on is the whole side of pharmaceuticals. I know a lot of individuals who work in pharmaceuticals as a chemical engineer as well. So in terms of job options, the sky is truly your limit, which is great, because almost every industry involves processes, and if a process is involved, chemical engineer is involved. So that is a really good starting question. And then to then merge that with the job market and post-graduation employment opportunity, and maybe linking it to myself specifically. As you're aware, I am pursuing my Master's of Engineering and Public Policy, and that's just because I wanted to learn more about how my engineering degree can be integrated into industries and government and more of the non-technical side of companies. So one thing that I'm really learning a lot about is sustainability and sustainability management in my program. So ideally, my post-graduation employment is something that deals with sustainability in an engineering aspect. So there are engineering training programs that do specialize in this area, and having a degree in chemical engineering supports my ability to best serve these positions. So that's something I see myself in, and an engineering position that links sustainability and understanding sustainability on a whole, not just on a technical scale. So I can throw it to whoever from our team wants to go next. Please feel free.
Yeah, so I will definitely go next. So my path is a little different from Sophie's. So in biotechnology, I personally don't know what types of jobs you would get from chemical engineering, although I assume they would be a little bit more similar. And exactly what Sophie says, you can really do anything with a chemical engineering degree. As far as after school, that was the second half, Julie, what was to do after school. So for me personally, I'm hoping to actually go to grad school and obtain a master's in chemical engineering in Sophie's program with a specialization in polymer chemistry. So I like polymers, like I said earlier. I like doing a lot with biochemistry, as well as organic chemistry is another part of me that I absolutely love working with in biotech. And I hope to do more around polymers and how we can use polymers to better further or even enhance certain parts of the body. So for example, using polymers as a way for tissue therapy or tissue regeneration.
Awesome. You're making me excited to study for my classes later on. That sounds so exciting. We can pass it on to Angel now. And maybe Angel, if you want to share also what you're looking at doing specific to your program after graduation.
Yeah, of course. I actually don't know because I'm only halfway through my third year. I still have another 4-month co-op coming up, so I'm going to definitely apply to see what other jobs I could be doing. And my answer to the question would be that I have no idea what I want to be yet, and I think that's okay because I still have time. And because my program is so diverse, I get exposed to many different subjects. Like I can go into anything that's related to like electrical, robotics, even chemical, or I can decide to go into the business side of things. So I do think that because the job market is so flexible, it's actually really hard for me to actually decide now as to what I want to do in the future.
Awesome. Thank you all so much for sharing. So it's really exciting to see just in our small panel here, how there's so many different opportunities within STEM. So I really like how Angel mentioned combining business with STEM. That's something that I really love. I'm taking a lot of business courses right now, and I'm really passionate about how a STEM background can support you in a business or consulting role. Consulting is something I specifically find really fascinating and really exciting. So there's just so many different opportunities with a STEM background that you can then explore in the workforce or in master's or PhD programs, which is really exciting. So we got a couple new questions. So thank you so much to our friends that are continuing to ask questions. Throughout the session, please feel free to continue adding those questions as you've been doing. It's very exciting. So we have one student that is asking about the different specialties. So I believe that one of the specialties of EngPhys is biomedical engineering. So how does this differ from iBiomed or biotech? That is a really great question. Just to focus in, so we're looking at the biotech program, iBiomed, and then also exploring biomedical engineering through other programs such as engineering physics, just to summarize that question. So Sophie, I know that you took that EngPhys course, biophotonics, I believe. So maybe if you want to touch on this question a little bit.
Yeah, I'm going to start by explaining what EngPhys Biomed, or what I think EngPhys Biomed specialization is. And then if you want to kind of touch on the biotech and maybe you can outline specific differences that you hear from me, I think that would be perfect. So the EngPhys Biomedical Engineering specialization really takes the principles learned in your engineering physics degree and basically applies them directly to a biomedical application. So like I mentioned, one of the courses I took that I'm sure is part of this program, it's called biophotonics. So understanding principles of biology, but more importantly, understanding principles of engineering physics in lasers, light ray optics in general, to then apply medical applications. So specifically looking at things like MRIs or light types of therapy were things that were really prevalent in that course. So I'd say in looking at equivalent courses in this specialization, you can look at different fields of engineering physics and see the medical applications in those. And typically with engineering specializations, these happen in your fourth year or in your latter years of the program. So you first need to understand the fundamentals of engineering physics before you can apply it into a biomedical specialization. So I hope that kind of answers that combination. I guess I can kind of touch on what is different between this and iBiomed. I would say that the substantial part that is different between EngPhys and biomedical specialization and iBiomed is that the iBiomed program starts from year one. So you actually take more courses that are science-based in relation to biology to make sure you have that fundamental iBio program, because it is inherent in your actual degree, not just in a specialization. And then you have a more fundamental approach of biology before you specialize in any type of engineering program as well.
Awesome, that's great. And then maybe Shelby, if you want to expand a little bit on the difference between iBiomed and biotech, or EngPhys Bio and biotech, that'd be great. If not, I can also add on as well. I know it's exciting that we're both from biotech, so lots of experiences to share.
Yeah, I like to point, like, for me, it's easier to see the difference between iBiomed and biotech and looking at what the end product is. So for iBiomed, you basically use engineering design and engineering principles to design concepts for medicine and healthcare purposes. Whereas with biotechnology, we study the same things. However, we hope to develop actual products, for example, pharmaceuticals, or even crops and livestock. So in biotech, for example, we learn about the ethanol process and we work on bioreactors to produce ethanol. Whereas for iBiomed, you may work around, for example, as Sophie said, working with lights and lasers for MRI machines and x-rays. So that's why I like to say the main two differences are, whereas for iBiomed, you're working for a medical field. With biotech, it's more broader and you can work with any field. So one of our main fields is agriculture. We can go into forensics when we work with DNA and genetic engineering. And we can also work with bacteria through our microbiology classes.
Awesome. Thank you so much. I think you did a perfect job of summarizing it, so we can leave that there and roll along with our next question, which is, how much harder do you find engineering than high school? So I know we all have different experiences with our academics in McMaster engineering, but maybe Angel, if you want to start us off and tell us a little bit about your transition from high school to university.
Yeah, for sure. Transition from high school to university I wouldn't describe it as much harder, because the specialty of my program is that we kind of have a common first year where we make sure everybody's going to start at the same place. We all take very similar courses among the 3 streams in BTech, so that really helps us to develop the fundamentals we need for later years. Academically, I wouldn't describe it as harder because I do enjoy the process of gaining new knowledge, so I do find it a very enjoying process. And in terms of other transitions, my experience is very different from a lot of, I would say, prospective students going into university, because I do come from an all-girls private school where I was not exposed to working with any male students before. So group projects and even just social interactions was a huge change for me. But I do find that process, it was fun. It was just kind of me stepping out of my comfort zone, and that was a fun process.
Awesome. Thank you so much for sharing that, Angel. Did anyone else want to share a little bit about their transition from high school to university?
I can. I can definitely shed some light. So to be quite honest with you, when I was in high school, I didn't really know what McMaster engineering really was, nor did I know about the biotech program until grade 12. So when I reached grade 12, I knew I wanted to go into chemistry. I loved chemistry, so I decided I was going to go into chemical and physical sciences, which is actually through the science faculty. And then when students from McMaster, specifically the BTech program, came to talk in my chemistry class, because they were alumni from my high school, they talked about their program. I realized that their program was a lot more suited for me because I am super hands-on and I love working in the lab, whereas the science program, the chemical and physical science program, is more research-based and doesn't give you a lot of lab time. So that's when I decided, ooh, McMaster engineering, it sounds exactly what I want to do. So I'm going to go into that. In terms of it being harder or easier, I actually found it to be a little easier, as Angel said, more because when you're in a specific program in university, you're able to focus on that program, and most of the concepts you learn in class actually kind of cross over. So for example, for Math 3, we learned about math, and it was all these math concepts, derivatives, integration, all of that. And then for a chemical engineering course, they would bring in those math concepts. So you weren't learning something new, you were just taking those concepts and advancing it. Whereas in high school, you have all these different subjects that don't mesh together whatsoever. You have to study for 8 different subjects, 4 in a semester. And yes, it looks daunting at university, but you realize all of your classes have similar names. So in one semester, I had molecular biology, cellular biology, biochemistry, and what was the other? Organic chemistry in a semester. They all sound the same. They all sound kind of similar, right? So you're not studying too many different things, nor are you too much outside of your comfort zone, because you chose this program so you know what you're here for. Whereas in high school, you have a lot of different things to focus on.
Yeah, I think that's awesome, Shelby. The way you explained a program integrating into similar subjects in upper year specifically, I would say second year and on even, is definitely how I felt in that transition as well. Personally, going from high school to engineering was quite a big step change for me, but that was just learning how to learn in a new environment. Lectures are taught in a different way, and learning in general is approached differently. But once I kind of adapted to my surroundings and learned about the different resources McMaster offers for assisting in courses, I found my transition to be a lot easier. So by second semester of my first year, I found myself much more comfortable than my first. And comfortable, I mean in an academic way. But specifically, I'd like to just touch on like the assistance McMaster offers to you to best assist you in that transition from high school to first year engineering, or any of the first year programs that we explained to you. So there are help sessions that happen every day. There are tutoring opportunities in which the McMaster Faculty of Engineering offsets a lot of the price, and there are a lot of people who are willing to help you learn the content you need to learn for your various courses. So I'd say, yes, it was a big step change for me, but once I adapted and took advantage of all the amazing resources, the transition was just that much easier.
That's awesome. Thank you all so much for sharing. I think you all shared really valuable advice to all of our students. Personally, I think that I kind of relate to all of the experiences you've shared a little bit. And something that I really had to get used to when I transitioned from high school to university was all of this time that I had. I know that sounds really silly, but in my high school, everything, and I feel like most high schools, everything's very structured. I knew I had my lunch every day at 11:30 to 12:30, and I knew exactly I was going to this practice after school, and my schedule was packed. And I liked that. I liked knowing where I needed to be and what to do and all the class time I had. And then when I got to university, I realized that I had a lot of class hours, but still a lot of free time in the day, because you don't always have that typical 8:30 to 3:30 day like you used to have in high school. And I had to learn how to structure my day so that I could study effectively and then get involved on campus so that I could fill up those extracurriculars that I used to love to be involved in high school, so that it could feel like more of a smoother transition and less had changed. So that's something that I really had to get used to, but there's a lot of time management tips and tricks that, like Sophie mentioned, the university will share with you and teach you, and you just really need to learn your own personal study habits and figure out what works best for you in terms of building your own schedule to help you be successful. So there's a lot of different information, resources available at university to help you with this transition for sure. So I know we're coming to the end of our session here. We're almost at 8 o'clock. So I guess I'll do just one more quick last call for any questions. I'm keeping an eye on the chat box. I think we just had one roll in. So what are the advantages, do you think, when comparing McMaster Engineering to engineering in other universities? So I can touch on this one a little bit first, and then everyone else can share their experiences. So when we're talking about McMaster Engineering, I like to just focus on all of the great things at McMaster, because there's so many great things about every other university. So I don't really like to phrase it that McMaster Engineering is better than this other university because of this. We're all amazing for our own reasons. And you really need to choose a school that feels at home to you. So there are so many different engineering programs within Ontario, within Canada, and the really important thing is that you feel comfortable at that school and that you love that learning environment and that you're passionate about it. So I think that we can all talk about maybe why we chose McMaster Engineering and what made it stand out to us when selecting from the other universities that we applied to. So I don't know if anyone wants to share maybe why they chose McMaster Engineering, why it was a bit of a standout to them. I can start us off while everyone maybe starts to think about their responses. Personally, something that really stood out to me was all of the clubs and teams available at McMaster. So I mentioned to you all that I really love to be involved in high school in like clubs and extracurriculars. Specifically, I actually love to dance a lot in high school. So I was looking for a program that allowed me to dive into STEM and completely immerse myself in my biotechnology program, but also allowed me to explore my other passions outside of STEM. And I thought that McMaster was a really great fit for that because it has so many clubs and teams and so many friendly faces that are looking to just meet new people. So that's something that really stood out to me, was that exciting community feel with all of the opportunities for extracurricular activities. If anyone else would like to share, feel free to jump in and select why McMaster stood out to you.
I can go next. The reason why I chose Mac was because how special my program is. Automation engineering and technology is actually one of the only, well, McMaster is one of the few universities that offers this program in Canada, and McMaster is the closest university that's to me because I'm located in Toronto. And I just really like the McMaster scenery vibes that it gave, because it's like a complete on a campus all gathered together. So I'm just only hopping like from buildings to buildings in between class times. When comparing to like, because I'm from Toronto, I know how UFT is like. So instead of hopping from like street to go to different classes, I do like the feeling of everything's all on one campus together. And yeah, McMaster and Hamilton in general has a lot of great scenery. We have really good trails, waterfalls, and that's just one of the reasons why I chose McMaster.
I'll just expand on that one Angel, because I totally agree. The whole visual scenery of McMaster was probably one of the reasons I went, and their amazing sense of community and making everyone feel like campus was home was probably my main reason for choosing McMaster. I think that the term is biophilia, which is the human tendency to go towards nature, and I totally feel that too. And that's definitely one reason I chose Mac, because it's just a beautiful campus with a lot of greenery, and you just really feel comfortable and happiest. And I felt happiest at Mac, so I'd say that's why I chose it.
So for me, I'm probably gonna just expand one of Angel's answers, which is it was one of the few universities that actually offered the BTech program. Next to this, in Ryerson also offered the biotechnology program. The difference being that this program actually had the co-op opportunity. So for BTech, it was a mandatory 12 months of co-op that you had to do, and they had a lot of resources that would help you at McMaster to get a co-op, which I thought was super important in getting that experience and having a program surrounded by just getting that experience, that after post-secondary experience, was super huge to me. And another big plus is that it was very close to home. So I am located in Hamilton Mountain, and McMaster is just near Dundas. So it was very easy decision for me to go to McMaster, actually.
Awesome. Thank you all so much for sharing. I think that is all of the questions that we've received. And also, I think that was a really nice way to end off our panel, is sharing why we all chose McMaster, which has become our home now for the next, I guess, 4 years to 5 to 6 for everyone's degree, which is really exciting. So with that, we want to thank you all for asking some really thoughtful questions. It's really exciting to share our experiences. We hope that we have encouraged you to further explore the amazing field of science and engineering and consider this in your post-secondary education. We also hope to see you this summer in some way, shape, or form, further exploring science and engineering with us and the Venture Academy team. So just a reminder to check out our website, which is youthprograms.eng.mcmaster.ca, to see our Venture Academy summer programs for all students. We're offering to students in grades 3 all the way up to grade 12. So feel free to check out the website for those summer programs, as well as our Leaders in Training program. So thank you once again for asking amazing questions and for listening to us today. We hope you have an amazing night. Thank you for having us.
I want to thank you presenters so much for your time tonight. That was an awesome presentation about McMaster Engineering and Venture Academy. And I just want to let all attendees know that BASF Virtual Activity Week is back tomorrow night for our last event. McMaster's Department of Chemistry and Chemical Biology is presenting the Magic of Molecules show, so come check us out again tomorrow at 7 p.m. Thank you so much.
Thank you.
Thank you for having us.
Thank you.